So today we are going to introduce a real-time digital human system called personaLive. Operating this system is actually very simple. Let's start with the demo so you can see the real-time effects in action. First, we need to select an image to act as your virtual avatar. For this image, the facial features need to be very distinct. We'll choose a photo of an Asian beauty here. Next, we click this button to upload the image, and then click to launch the system. At this point, the camera turns on. It captures my current facial information, including my head movements. The overall effect is quite good, and the latency is very low. Now, let's talk about my personal experience testing this. Regarding the real-time effect you just saw, I think that part is fine. However, I feel the biggest drawback is the eye contact. For example, right now I am using a laptop to show you this video. My eyes have to constantly stare at the laptop screen. This means I am not looking at the camera lens. If I look at the screen, notice this, the avatar's gaze starts to wander downwards and the eyelids droop. The whole effect degrades. This situation is different from when we record videos with a camera or do a standard live stream. So I think it would be much better if an eye gaze correction model were added in front of this model. The system we are using today, personaLive, was released about 2 weeks ago. When I first saw this system, I wasn't particularly interested. That's because I felt its base model was too outdated. Take a look. It uses SD image variations, diffusers, which is what we call SD 1.5. This is the model everyone used back when we first started doing text to image. Since then, technology has iterated constantly, upgrading to Flux or even stronger video generation models. However, we cannot ignore one problem. We need a real-time effect. So, when analyzing the technology later, we realized this kind of application might be necessary. Let's look at the system. It has some demos here. It supports both real human characters and anime-style virtual characters. Currently, they have released the corresponding inference code, and there is support for it in compshare. However, we will not be demonstrating this function in compshare today. Why? Because currently inside compshare, it does not support this kind of real-time effect. You can only use the offline method. That means you give it a driving video, then give it a face, and it generates a new video. But regarding that kind of result, many of our current models already do a fantastic job. Its biggest feature is the balance between quality and speed. So if we step away from the concept of real time, its importance drops significantly. There are two ways to deploy the system: cloud deployment and local deployment. If you choose cloud deployment, we usually access the system like this: IP address plus the port number. When using IP and port, the system typically does not have an HTTPS connection. You'll see here that it shows the link is not secure. What problem does this cause? The camera cannot be accessed. For example, let's upload a reference image and click Fuse Reference. It says upload successful. Note here, please lower the frame rate a bit. 25 frames is a bit too high. Generally, based on your computing power, I suggest setting it to 16 or 15. If you set it too high, it will often lag. Now, if we start the system, you will encounter this error. The error is quite clear. It cannot find the corresponding device. The reason is that if you are not on an HTTPS system, it has no way to invoke your camera. So what do? Pay attention here. You can open Chrome, flags inside. There's a section called Experiments. These are experimental settings. There's a setting here similar to a whitelist. Insecure origins treated as secure. This means regardless of whether these websites are accessed via a secure HTTPS link, I will trust all operations from them perfectly. You just need to copy your cloud server address, paste it in here, and make sure you set it to enabled. After that, we need to relaunch the browser. Now, it will ask, do you want to allow the use of the camera? I click Allow, and there's the effect you are seeing now. So this is a critical issue to note when accessing the system. Next, let's look at the system installation. There are many choices, mainly depending on your operating system. Here, I am using an Ubuntu system, so this is a Linux installation method. For Windows, the basic situation isn't too different. Let's demonstrate. First, come to the personaLive GitHub page. Down here, there are specific installation steps. Take a look. But before doing these steps, I must emphasize, you must understand your base environment. If the base environment is incompatible, you will easily run into problems later. What do we mean by base environment 3? Very important elements. First, CUDA. Second, PyTorch. Third, Python. How do we get this environment? You can see this code here. It creates a virtual environment via Conda using Python 3.1. Oh. Also, if you click Open Requirements, you'll see Torch is 2.1. If Torch is 2.1, our CUDA is generally 12.1. So let's detect our system's base environment first. On Ubuntu, we can use mvccv to check the CUDA version. Look, mine is 12.1. Then we can use piplist vertical bar grep torch to check the installed Torch version. Look, it is 2.1, then check the Python version, and it is 3.1. Oh, since the base environment is fine, we can proceed directly. Next is the standard installation method. First, we clone the code. Generally, as long as your network is fine, this executes normally. Then we need to enter this directory. Now we install the dependency packages. Note that there are two dependency files here. One is called requirements ID base, and the other is requirements TensorRT. Their functions are different. The base one is the dependency we must use to launch the system. The TRT one is used when generating the accelerated model. If you don't need to generate the accelerated model later, you don't need to install that one. So let's install base TXT first. This process usually has no issues if your base framework matches the system requirements. Now we enter a very important stage, download weights, which means downloading our models. It provides a download script called download weights py. You can just execute this download program directly. If downloading that way isn't convenient, they provide manual download options, Google Drive, Baidu NetDisk, Model Scope, and Hugging Face. Choose according to your situation. If you download manually, the basic model structure looks like this. A common mistake people make here is forgetting to download the JSON file. Without this JSON file, it cannot execute normally. Also, right now inside the Tensor directory, we only have an ANAT-work engine. This is an engine file. Up to this point, the basic installation is considered complete. If you have no other special needs, you can do offline inference. Some ask, what is offline inference? That means simply taking a video, giving it a face, and converting it to another video. You can use it that way, but as we said before, that approach seems meaningless for this tool. So we must proceed further. First, we need to install the acceleration, because if you want to do real-time inference, it is different from offline. Real-time requires very low latency, so we have to find a way to increase the speed. Here we use a technology called TensorRT. Many people have used this. Sometimes we use it in CompUI too. First, we do an advanced conversion of the model so it can run in this TensorRT mode. This way, the speed on the graphics card will see a significant boost. They mention a 2x speed increase, but the downside is you need to convert this model in advance, and the conversion time is often very long. Before converting, you need to install the second requirements file we mentioned earlier, requirements TRT. If you don't need to convert the TensorRT model, obviously this step isn't needed. Okay, let's install it. During the installation, I got an error. This error is actually very clear. Take a look. It says GRT, command not found. So if we need to compile and install some programs, the GI command is mandatory. Let's install it. Those who do system operations frequently should be very familiar with this. If you aren't, you can search for it or just use my command before installing. I suggest using apt update to update your installation sources. Then we install a tool called Build Essential. This is a basic compilation and build toolkit, and it contains the GI thing we talked about. We wait a moment, then we install the requirements TRT file again. Okay, now the installation is complete without any errors. Next, we need to convert the model. They gave us a corresponding conversion script. We just execute it directly. This time will be very long, and during the process, you might encounter RAM overflow errors. If the program hasn't stopped running, you can ignore this because if a RAM overflow occurs, it will try other memory optimization methods. You just have to wait for it to finish. Finally, check if the converted model exists in your system. How to confirm? Go into the system you downloaded. There is a folder called pre-trained weights, and inside is a subfolder called TensorRT. Let's see if there is a file there. The new converted model is called UNATWork. Note that its size is about 3.4 gigabytes. So if this model exists, it means the conversion was successful. Next, we need to do the front-end deployment. This is relatively simple. First, let's install Node.js. The method we use is via NVM. First, we download the NVM installer. Then, through NVM, we install the specified version of Node.js. This usually presents no problems. Then we compile the front-end program, go into the webcam subdirectory. Then we execute start.sh. As you can see, the front-end directory is built. After that, you can use the command below to launch the system. The command itself is nothing special, inference online. Then comes the acceleration mode. This must be selected correctly. Since we just converted the model to the TensorRT method, you must select this acceleration mode. Let's execute it. After startup is complete, you can see it has started listening on port 7860. Then you can open the interface we talked about earlier. Again, you need to put the current domain into that whitelist we mentioned. And remember, after you are done using it, remember to turn that flag off, because this is experimental and generally not recommended. Also, when you launch Chrome this way, it will warn you every time that you are using a command flag, which lowers security. So switch it back when you are done. Let's wrap up with a summary. Overall, the quality of the conversion isn't necessarily the best, but in terms of the balance between quality and speed, its performance is fantastic. If you truly have a need in your live streams to convert your image into a virtual human in real time, I suggest you choose this system and give it a try. Okay, that's all for today. Follow me to become someone who truly understands AI.